This is Woodman here with another channel message. Tardigrades, often called water bears, are remarkable microanimals known for their extraordinary resilience. They can survive extreme conditions that would be lethal to most other forms of life, and here are some key ways they can achieve this. Cryptobiosis. Tardigrades can enter a state known as cryptobiosis, effectively suspending their metabolism. In this state, they can endure extreme temperatures from just above absolute zero to over 300 degrees Fahrenheit, high levels of radiation, and even the vacuum of space. They achieve this by losing almost all of their water content, curling into a ball, which then protects their cells. Desiccation resistance. By losing about 98% of their body water, tardigrades can survive extreme dryness. They replace the lost water with a sugar called Trehalose, which stabilizes proteins and membranes, preventing damage during dehydration. Radiation tolerance. Tardigrades can withstand radiation levels hundreds of times greater than what would be lethal to most humans. They have unique properties and DNA repair mechanisms that protect their cells from radiation damage. High pressure survival. These tiny creatures can survive extreme pressure, such as that found in deep ocean trenches. Their cellular structures adapt to maintain functionality under these conditions. Cold and heat tolerance. Tardigrades can endure freezing temperatures and extreme heat. Their proteins and membranes are especially adapted to function even within these extremes. Chemical resistance. Tardigrades also resist harmful chemicals, including many toxic solvents. They can tolerate high levels of alcohols and other chemicals, likely due to their ability to rapidly repair cellular damage. Longevity. In their cryptobiotic state, tardigrades can survive for decades without food or water, allowing them to endure long periods in very inhospitable conditions until they find a suitable environment. Typically, the average lifespan of a tardigrade ranges from a few months to several years, depending on the species and the environmental conditions. Tardigrades are in microscopic invertebrates that have essentially survived, pardon me, on Earth for about 500 million years. And so they're thought to be able to survive for centuries. These adaptations make tardigrades some of the toughest organisms on Earth, and so they survive in environments that would be pretty much a death knell for just about every other type of creature. Tardigrades have also survived all five mass extinction events on Earth. Tardigrades are thought also to be able to survive astrophysical events like gamma ray bursts or large meteorite impacts. Of course, unfortunately, they probably won't turn into a green monster known as the Incredible Hulk. Microscopic animals that can survive a broad range of environmental stresses, tardigrades possess a unique set of tardigrade specific intrinsically disordered proteins, which are known as TDPs. And when they're expressed at high levels in tardigrades, it seems to mediate stress adaptation and keep them from suffering certain types of damage during desiccation. Some researchers believe that tardigrades are so resilient that life on Earth could extend as long as the sun keeps shining. They also believe that tardigrades could be a sign that life is possible on other planets. The free-form proteins of tardigrades are considered extremely unique due to their specialized structures and functions that enable the organisms to survive extreme conditions. Let's talk about some of the key features of these proteins that make them unique and how they help. Stabilization during desiccation. Tardigrades produce proteins that help stabilize their cellular structure during dehydration. For instance, the protein Trehalose binds to and protects proteins and membranes, preventing denaturation and aggregation when water is scarce. DNA repair mechanisms. Some tardigrade proteins are involved in repairing damaged DNA. This capability is crucial for survival in environments with high radiation levels where DNA will be harmed by the exposure to these radiation levels. Heat shock. These heat shock proteins that tardigrades possess allow them to refold damaged proteins and protect cells during the exposure to these extreme temperatures. These proteins play a crucial role in maintaining cellular integrity even under stress, which would not be possible in many other creatures. Unique protein structures, as we've mentioned, tardigrade proteins have evolved these unique structural features that allow them to remain functional across a wide variety of environmental conditions. This includes flexibility and resilience that enable them to withstand the extreme pressure, the extreme temperature, as well as the extreme radiation. Stress responsive proteins, and so some of the proteins are upregulated in response to stress, allowing the organism to quickly adapt to sudden changes in their environment. This includes proteins that can help mitigate oxidative stress caused by those extreme conditions. Molecular chaperones. Now, that's interesting, right? Tardigrades have an abundance of molecular chaperones, and I don't think the kind of chaperones you see on a date, right? That assist the protein folding and prevent the aggregation under stress. This is crucial when the organism is in a state of cryptobiosis and must quickly resume normal functions upon rehydration. These unique proteins contribute to the tardigrade's remarkable ability to survive extreme environmental challenges, making them one of the most resilient organisms on Earth. The unique adaptations are a subject of extensive research studied by scientists across the world, with potential applications in fields such as medicine, biotechnology, and astrobiology. In other words, taking some of these unique structures that are present within the tardigrade and adding them to things like bacteria or other life forms has demonstrated that when adapted properly, that this also provides remarkable resilience and the ability to survive to these other organisms that the different proteins and other genetic or molecular structures that tardigrades possess is added. And that means that, of course, at some point, we may start to manipulate life itself using what tardigrades have to make people more long lived. I suppose inevitably one day that might be also added to human DNA structures. Of course, obviously, there are a lot of ethics issues that get raised with doing something like that. If you enjoyed this message, please like, share, and subscribe. If you're new here, welcome aboard the Safe Space. If you're returning, I'm glad that you're back. I love you so much. You keep the show going. In the name of the Most High God, I wish you health, wealth, prosperity, and abundance, as well as blessings and protection if you so deserve it. Woodman signing off. Have a great day. Bye.